Good to see you. My name is Mike Stolz. I go back a long way with the Gemfire product. As a matter of fact, I go back all the way with the Gemfire product. I was the very first customer to put Gemfire in production almost 15 years ago. I joined the team as VP of Architecture in 2007, and then lived through the VMware buyout, well actually the SpringSource buyout, then the VMware buyout, and then the pivotal spinoff. So here I am after all these different incarnations, still doing exactly the same job. Serving right now as the product manager for Gemfire. Okay, we're going to talk about some of the key features of Gemfire and kind of how that applies to how and why you might use it. But the one thing that I think has been a repeating theme today here has been that data-driven smart applications are the key to innovation and the key to being the disruptor, not the disrupted. And I think that that's true across every industry. Right now, if you look at airlines, they're all doing all kinds of things with apps to try to make your overall experience better. They're trying to do better things on the airplanes themselves to try to make your experience better. You go with people who are doing farming, the carb, what do they call them, carbines? Yeah, carbines. Those things are actually just loaded with computers and sensors now. They're testing the soil before they put fertilizer into it, so they put exactly the right amount of fertilizer into it and all that kind of stuff. So it's everywhere. One more repetitive slide that you've seen a few times today already. Open source is key nowadays. And as of this year, Pivotal has become a completely open source company. We have almost nothing that's closed source at this point. We had already in the past Spring, Tomcat, Cloud Foundry, all of that was all open source, right? And there was more. And then we had the 3 data products, Hawk, Green Plum, and Gemfire were all closed source. And this is the year those all became open source too. So we are an open source software company. Now, so there's a lot of people on the journey, a lot of people who want to get to, microservices and a modern day architecture and all of those things that we've talked about so far today. And I would venture to say that most enterprises aren't there yet. They either have a bottleneck at the database layer, or they're still doing old-fashioned ETL or ELT. What they're not doing is what I call the full cycle of data apps and analysis. And I think that we as Pivotal are in an ideal position to try to help get companies, and especially enterprise-sized companies, into that space where they can start to take advantage of what we're postulating here. And I do think that toward that end, that Apache Geode, which is our open source in-memory data grid based on Gemfire initially, now we say it the other way around. We now say that Gemfire is based on Geode because we have completed the open sourcing of Geode. So we started off with that work in February 2015. We have completed our milestone 3 release of Geode. We are about to release 1.0, no longer incubating, very, very soon, and that will be the basis for the 9.0 version of Gemfire. So, having said that, Gemfire is really all about being able to get predictable low latency in a horizontally scalable and elastic fashion. So it's easy to get low latency and predictable low latency in a single node database. It's much more difficult to get that same kind of predictability in a horizontally scalable database, and especially to continue to get that even while you're scaling it, which is one of the interesting things about Gemfire, is that even while you're scaling it, you'll still get your predictable low latency. When we talk about low latency in the Gemfire world, we're talking about hundreds of microseconds if something takes 2 milliseconds, that's a problem. So we're really down in those hundreds of microseconds range. I wanted to talk a little bit before I leave this slide about some of the customers who are using Gemfire and using it big time. So I'll mention first State Farm. It's an insurance company in the United States, the largest auto insurance company. And they are using Gemfire, actually not just in auto, they're using it in auto, fire, homeowners. They're using it in many, many areas of the company. But one of the interesting use cases that they're doing is they have this little thing that you plug into your car that monitors with a couple of accelerometers just how fast you're driving and cornering and doing all that kind of stuff. And if you're a good boy, you get a discount. And if you're a bad boy, you get penalized. So.
Tell us this now.
Another one that I think is really, truly amazing is Southwest Airlines has reached the point where they've put so much of the airline on Gemfire that if Gemfire isn't running, they can't fly. They run flight ops, crew, and cargo. They started out just running southwest.com. So when there's a weather issue, when there's any kind of a situation where they need to rebook people, Gemfire is in the mix on that. Every time they need to do a crew adjustment, Gemfire is in the mix on that. Who else shall I talk about? China Rail and India Rail, two interesting logos there. So between those two railroads, we probably, and Southwest Airlines, we can probably safely say we move more than 50% of the world's population. And then I like to talk about Ford because it was a recent big win for us. Ford is to the point where they believe they are no longer just a car manufacturer. They believe that they are going to be a transportation manufacturer. And that means the entire set of logistics around that. People will probably not be buying cars as much in the next 10 years. They will probably be using services where the car drives to them, picks them up, and there's no driver in that car, and takes them to where they're going. And Ford really believes that. And so in a few slides, I'll show you what Ford did with it, did with Gemfire. Okay, I do think that the other thing that's really important about our message this week or today is the whole notion of Cloud Foundry. So you guys are here in the data group, the data sessions, but Cloud Foundry is very, very important, I think, to the future of enterprise. I think that the notion of being able to write your application, deploy your application in such a way that you can go on Amazon, you can go on Azure, you can go on on-prem, you can go on VMware, you can go on Docker. It shouldn't matter to you. Your IaaS shouldn't matter. The platform should insulate you from all of that. So Gemfire is one of our services that does run on Cloud Foundry, does run on Pivotal Cloud Foundry in particular. And it supports, we are currently in production on VMware in several sites, AWS and Azure. So I said I would mention more about what Ford did. They did this application. It's a mobile app called Ford Pass. Ford Pass went live with Gemfire on Cloud Foundry early 2016. It's kind of a little bit of a strange app. One of its features is it'll find you a parking space. It'll also find you a service center. So it does a whole bunch of things to improve the user experience with the car, including connecting to the car and being able to display GPS stuff on your screen on the car and that kind of stuff. Now, Ford chose PCF for a couple of big reasons, most of those big reasons being that they didn't want to be locked in. Cloud Foundry is a way of avoiding lock-in. IBM has a Cloud Foundry product. Pivotal has a Cloud Foundry product. There are many other vendors that have Cloud Foundry-based products. They chose Gemfire in particular as the mechanism for storing data as system of record for Ford Pass. because primarily of its ability to do active-active multi-site. So they have a site in China to handle mostly China traffic, and a site in Indiana to handle mostly US traffic. And they can fail over between them, and people can migrate between them easily. So fully active-active multi-site. Any questions up to that point? Okay, so now I'm going to dive into what makes Gemfire special. Okay, so that's a few ways people have used it. So, some key features. It is, I'm going to read this slide. I don't read many of my slides, but I'm going to read this one. It is horizontally scalable and elastic. What does that mean? It means that you can add nodes, you can take nodes away, you won't lose data, and you'll continue to have your predictable low latency. We're talking, remember, less than millisecond latency, even when you're in the process of adding a new node and rebalancing. Okay? Memory-oriented. That means we have a very strong affinity to using memory for everything that we can, but we do have durability if we're asked to. So on one of my next slides, I will show you that there is a mechanism by which you can actually use Gemfire to give you the D in ACID as well as the ACNI. Active everywhere multi-site. I have lost count of how many multi-site global installations we have, but it's in the thousands, and it is the WAN gateway feature, the active-active multi-site feature, was the #1 feature that caused me to purchase Gemfire when I was their first customer all those years ago. I needed active-active multi-site. They had it, and arguably, theirs is still the best of the active-active multi-site capabilities of any of the in-memory data grids today. The others just, they do not have the throttling, they do not have the conflation capability, they do not have, that's the ability to not send repetitive changes. They do not have the bidirectionality, and they do not have the durability built into their solutions for this. And then I go and I say KeyValue object store. Wait a minute, we don't usually use those words together. KeyValue store or object store, which is it? It's a KeyValue object store. Your value can be any object you want. Now, it's important to understand why memory is a big deal. Take a look at these numbers. These are orders of magnitude. That's a very, very, very much slower thing to read from disk than it is to read from memory. And we want to be very careful about how many of these we do. So the read from disk is going to be this plus this plus this. The read from memory with Gemfire will typically be this plus this. You're going to have a network hop, but you'll have one. So here's where I was saying that you will be able to optionally get the durability. What we do is we give you the option of saying that I'd like to have this table be persistent, please. And if you ask us to make it persistent, you can ask us to make that be synchronous, so that it's going to be very, very reliable, or asynchronous, so it's going to be very, very fast, comparatively speaking. We think that the reliability level that we give you by putting 2 copies of the data into 2 separate memories on 2 separate computers and flushing it into the operating system disk buffers, but not all the way to the disk, is reliable enough for 99% of the cases. Now, there's another thing that Gemfire has built into it, and that is a very powerful eventing mechanism. It's a real-time active architecture. The idea being, data can be coming in very rapidly, data can be changing very rapidly. You have some things that you care about in the outside world. Maybe you're trying to detect fraud, and so you'd like to be able to see, has this credit card been used 3 times in rapid succession? There's all kinds of rules that they apply to fraud detection. So we can actually do various different kinds of filtering inside of the in-memory data grid and push out events to your app server for the things that the app server says it cares about. That's a very powerful feature. You can imagine some of the things you could do with that. I mean, just start to let your mind work. I can be pushed the good ones that I care about. I don't have to poll. Okay, so now I'm going to give away the big secret of why Gemfire is so fast. And it's this slide and the next slide. I'm giving away the whole store right here. Okay, so we have a notion of partitioning. Now, our word for partitioning is different than Ivan's word for partitioning. Ivan talks about partitioning as being a vertical thing. We talk about partitioning as being a horizontal thing. Someday we'll come to an agreement on which one's right. Probably Ivan's. We should be calling it sharding. That's the name that this has taken on since we coined partitioning many, many years ago. But we were first, so we should have gotten the right to say which one it was. Anyway, we do the same thing that Hadoop does. We shard the data, and the same thing that Plum does. We shard the data across many nodes, and we are able to run your transactional workloads on those shards, but we place some limitations on you in order to make it really fast. So if you were to take data and scatter it arbitrarily on a network of nodes, what you would end up with, and didn't have any notion of a collocation hint, what you'd end up with is your transactions would all slow down to the speed of the network. I could go back to the number. Anybody remember how much slower the network was than the memory? Yeah. 2 orders of magnitude. Okay? So we don't want to be slowing our transactions down to the speed of the network. So we give you a mechanism by which to tell us that you have data that is collocated. In this case, I've picked a very, very, very simple example. I've got customers who have orders, that there are shipments associated with the orders, and there are payments, okay? And so if I can take that data and I can shard it in such a way as to line it up so that the customer record, the orders, the shipments, the payments, they're all on the same machine in the set of machines that are sharding all of this data, then even though I'm horizontally scalable and can use thousands of computers, I can give you the speed of a single computer for your transaction. Okay, so in-memory speed transactions. Now, that works great for one-to-many or many-to-one relationships, but every data problem has a many-to-many relationship somewhere. So we actually modeled that problem first, and we modeled the sharding problem second. So we actually built what we call replicated regions before we even built the partition regions, knowing we were going to need to handle many-to-many relationships. And so what you do is you take your reference data, things like product descriptions and pricing data and stuff that doesn't change often, but everybody needs to see, and you put that in replicated regions. Those regions will be, quite literally, replicated to all of the nodes in the cluster. So we're wasting some memory in order to get rid of that network hop. And you're in control of how much memory. So I keep harping on this grow and shrink dynamically, and I really believe it's important because it's one of the huge differentiators between Gemfire and the other products in this space. We have seen reports from users of the other products in this space that those products are so aggressive about redistributing the data or resharding the data or what we call rebalancing the data that they actually consume all of the available network bandwidth, and you can't run your business anymore until they finish that rebalance. We will never use all of your existing bandwidth during a rebalance. Your business comes first. We have a notion of something called DataAware function routing, which is different than MapReduce. Okay? This is a case where you are going to execute the, add shipment on behalf of this customer's order. So we want to go ahead and route that function that's going to add the shipment. This is a Java function running inside of the grid. We're going to execute that function right on the machine that has the primary copy of the customer record, the order record, the shipment and payment. Okay? So a single hop operation for the stored procedure that you wrote in Java. And we also have the simpler case of MapReduce. So you can go ahead, you can do parallel execution, do any kind of aggregate kind of thing you want to do, and you can really take the full advantage of a MapReduce style operation. Our API is a little easier than MapReduce, but it is still Java. You don't have to write the reducer. We wrote the reducer already. Okay. I should stop there because the next part is a different thought. So any questions up to this point? Wow. I must be doing this too well. Okay. So I did say something about ACID earlier. So you are having some expectation that I must have a consistency model. And I do. The consistency model within a given Gemfire cluster is synchronous consistency, just like you would get from any other database. Okay? So when you commit, it's all or nothing, and it's on both the primary and the secondary. When I go to a second cluster that's geographically separated from the first, you don't want to pay that time for all of that network traffic as part of your commit. So that is asynchronous and what we call eventual. So our guarantees around that eventual consistency is that at any point in time, you will be inconsistent up until such time as we reach consistency again. That's an important concept. It means that you need to think about multi-site active-active patterns for avoiding collisions. Because if Les goes ahead and updates record A, and Ivan goes ahead and updates record A from two different locations, last one wins. Okay, so you do need to have collision avoidance tactics in place, and we have a whole set of collision avoidance tactics that I could go through with you if there's time to help make that an easier task. Also, typically eventual consistency, if we're talking to some sort of a backing database, when we talk to Green Plum, it's an eventual consistency model there as well. We offer ourselves as a external table, but we're batching really under the covers. So we have a couple of ways of doing multi-site. This way that I'm showing now is a single cluster that is spanning data centers. So it's two sites that are close together with less than a millisecond ping time between the two sites. You're getting effectively a recovery point objective equal to 0 and a recovery time objective equal to 0. There's no other database on the planet that offers that. Typically, we're deployed this way. We're deployed with the bidirectional WAN gateway between the sites. We're usually deployed much farther apart than 1 millisecond ping times. And so you might have an issue of some amount of data loss in the event of a full-blown disaster. So your recovery point objective is not quite 0. You have some control over how far from 0 it is. You tell us how big the buffer should be before we transmit it, and you tell us how long to wait for the buffer to fill up in the event that it's not filling up fast enough. So we typically keep that buffer the same size as the MTU buffer on your network, which is only 1,500 bytes. So you're not going to lose much if you're going to lose anything. Okay? This is an interesting way of doing multi-site active everywhere. This is a case I'm working on right now, in fact, with Southwest Airlines. They currently use the stretch cluster across two sites, but there's an inherent problem with that. That cluster could get stalled during replication if there's an external network issue, right? This is a network they don't control, and so if there was an issue with that network while they are doing synchronous replication from the primary to the secondary, that primary could get stalled. Just for the one key, but it still is a stall. We don't like stalls. Okay? So what we are recommending to them is that they put 2 of those clusters in place on 2 different external networks, and have them bidirectionally replicate to each other. And guess what? Our last one wins mechanism is exactly what they want in this particular case. They really will still wanting to be primary in one place or the other, but they'll be able to get what they need. Okay, so we've talked about Gemfire being all primarily in memory. We really don't like to overflow to disk. I mean, we have customers that talk to us about, oh, could you overflow the data to disk and not keep it all in memory and just page it in when you need it? And then we say to them, well, then you're just doing what Oracle does. You're not doing microseconds anymore, so what's the point?
It's SAP over in Europe. You get your point.
Yeah. So we've been growing the ability of Gemfire to do more and more and more and more and more memory over the years. And we have finally gotten to the point where we can't push the Java garbage collector any harder than what we're pushing it now. We have reached its limit. And so what we had to do was we had to come up with a different way of growing. And what the different way is that we wrote our own collector that manages memory that is not on the Java heap. So the garbage collector doesn't know anything about this memory. It's in the same process with us, but it's not in the Java heap. And because we have incestuous knowledge of what's going on inside of here, what kind of data we're storing, and for how long, our collector is able to do defragmentation and coalescing. That's actually what we call it, is coalescing, without doing block moves. So we never have to do a stop the world GC. Okay. And we know all of it's tenured space. That's what you're using a cache for. It's all tenured space, so we don't have to deal with having generational garbage collection. So what we do is we leave the keys and any working buffers be in the regular garbage collection scheme. We move all the data out to the OffHeat scheme. And it's, one interesting side effect of that is you can make your heap take advantage of a feature of Java, which is that if a Java heap is smaller than 32 gigabytes, Java can use a short pointer instead of a long pointer for every pointer that it uses. And so you actually get much, much more efficient usage of your memory. So not only is it faster to garbage collect, but it's also way more efficient. In fact, I've seen people take the heap from 32 up to 48 and be able to put not a single bit more data in. That's how much overhead those pointers are.
So simply said, our garbage collection is much more about the throughput and the latency than the capability to address more memory. Yeah?
I'm sorry, Count.
Yes, I'm just thinking about it.
We should give you the microphone, actually.
What is the main purpose that we develop our own garbage collection? Yes, this is not about the capacity, definitely. Yeah?
Well, so let me go back to that slide. I'll point it out. So here, if we have a heap that's 256 gigabytes, that's going to give us very slow collections, okay? Extremely slow. If we take that same setup and take 226 of that and put it here in the off-heap space and keep the heap under 32, those collections, we know how to keep those collections, those pauses down in the millisecond range.
Okay. So, but still, that's the part which is Java heap. It's been managed by the original Java garbage.
Yes, this part stays in the regular GC.
Okay. Your code's blind to the other memory.
It doesn't even know it's there.
Doesn't even know. Brilliant. That's I did not know that.
And this 30 gig is a reasonable size. Can we, for example, shrink it to?
Oh yeah, sure. Yeah, you could shrink it. Yeah, so 30. It just so happens that on most Gemfire workloads, 30 gigabytes happens to be the sweet spot. It happens to run best. If you're doing a very heavy update type workloads, then you're probably going to want to shrink it.
Okay.
If you're doing very heavy query workloads, you also might want to shrink it because queries make lots of garbage. So sorry, Ivan, queries make lots of garbage. Yeah, so I didn't really push that point, and I am going to push it a little further just for a second. I said earlier that it's a key value object store. And I pointed out that there's a way of using foreign key mappings to keep the stuff co-located. But what I didn't point out that I should have, we do as much as possible key-based. We don't query. Query is an empty pattern in Gemfire. So the OffHeat memory is new in Gemfire 9, which means it's not quite released yet. It's just about to come out. And the integrated security is also new in Gemfire 9. This is going to give us a way of, so we've always had security in Gemfire, but you had to write Java code to implement it. We've made it so that we've written the Java code for you, and now you just configure it and just set up groups and permissions, and that's it. You just do it that way. And I think we mentioned it earlier, we now have this Gemfire and Green Plum connector that makes big data and fast data meet somewhere in the middle. We've actually had this thing in a non-production form for, boy, a lot of years already. But we finally have gotten around to productizing it. And so that's coming out in Gemfire 9.0 as a beta feature.
With 9, it'll be GA.
Oh, will it? Okay. That wasn't. Okay, cool. So we should get it into the 9.0 beta then, because that's just about to come out the door.
Question to both of you guys. We should meet the level of the version, both sides. Yeah. So the Gemfire 9 and
So Green Plum it should be any 4.3.
4.3. Okay.
But Gemfire, we're
So-
targeting it with Gemfire 9.
Yeah, Gemfire 8 is too close to end of life to put a new feature into it, so we're putting it in 9. Okay, so that was everything that I had slides for, unless you would like me to cover something like the active-active collision avoidance design patterns. Love to cover that for you. That would be easy to cover. How much time do I have? I have enough time to do that.
I think 20 minutes long, no?
Yeah,
I got one question.
go ahead.
On your eventual model with the orange arrows,
Mm-hmm.
is that 100% dependent on external things like network implementations and stuff like that? Or can you guys make any inroads to affect how long eventual is?
Well, we're still bound by the network.
That's what I mean. Is it, so if they speed the network up, then that's going to get better?
Oh, yeah.
It's gonna get worse?
Yeah. So now the data loss part is a different part of that.
Yeah, yeah, yeah.
That's how much we're buffering.
Yeah.
Once it gets on the wire, it gets there, right?
The eventual is like somewhere else.
So it's
How
southwest
long
of using
eventually is?
Galileo, it's Galileo's problem till it gets there, yeah?
Yeah.
Okay.
Okay. I think it's
What's
wait.
your experience of what eventual means? And I know that is how long is a piece of string, but Imperial College say 3.6 inches, we're done. So,
Over and above the network transfer time itself, we typically see people setting it to on the order of a few milliseconds.
right, so again,
It's 1,500
that's
bytes
not
getting
what
into
I
a buffer.
expected you to say, you see, which is good, okay.
You thought it was going to say multiple seconds.
Yeah, yeah. But
Counting it
then
milliseconds.
you've got to put the network in the way, I get that. But
How do you typically populate the Gemfire with data? Is it coding or is it some configuration?
Well, so you can use actually Spring Cloud Data Flow as an engine to pull data from anywhere, maybe do a transformation on it on the way in, and then go ahead and hand it into Gemfire to get it the initial load up. When you're using Gemfire as a system of record, it does have its own durability. So if you're just pushing transactions into it all day long, it'll just safe store those to disk. When you do a shutdown and restart, it'll load from disk. Then the third way is to do lazy loading when you're using it as a cache, and that means every time there's a cache miss, it'll go out to some backing database and pick up the thing that it didn't have.
What I didn't find in the documentation is some kind of design patterns. How do you design practically some typical situations like, because you have the key value only. So in real life you have multiple tables that in database environments you can connect with the SQL. How do you
You're using that J word,
Gemfire?
join. Oh, you're asking how do you do joins? Joins are an anti-pattern in an object store. You build your objects to not need joins. Your order record contains items. You don't have a separate items table.
Yeah, but if sometimes you want to ask for the subtable, so you want to have keep two tables, yes, I understand. So you are looking for the value in a key value store first, and then look in the other table to find another. And
You're saying where they're not distributed based on the same keys?
sometimes life is complicated, yes? It's not like linear.
So then basically what he's saying is that you push into memory something that's not complicated. So that you can, by making the schema not complicated, you can get HA across the whole globe with 1 millisecond response to millions of people. You take the complication to a more back-end system, like where you're going to do analytics to do bigger queries and then maybe get the results and then push the result set into the in-memory. But if you want to have that high availability millisecond, then you keep that as simple as possible so that it can respond.
And definitely use containment relationships rather than joins.
Do you need to fiddle with your schema? Makes sense to you.
Yeah.
You do, yeah. That's why you go and do the analytics or the complicated stuff kind of not in real time. And then populate the real-time system only with stuff that can be real-time, meaning it's co-located.
I think that there is a fundamental difference in between modeling inside a Hawk or Plum and in Gemfire,
Right.
and I need your feedback, Mike. So for instance, in Plum we have customer building data model with 100 of table, 1,000 table, even 12,000, like we discussed today. On Gemfire, I think the modelization is completely different because according to what I heard from customer, you have very, very small data model, so it's, we are not in the same range. So the question regarding join is, is disappearing because you are building object and the data model is pretty small.
So you're bringing a combination of tool sets, right? You
Yeah,
don't-
but the model itself, like say, the object itself could be complicated.
Yes, for sure.
We've just discussed, for example, the object could be the JSON file. Yes. So structure.
But you would still have, let's say, a key, for example, like based on a customer ID, and then you'd store all the data for one customer on the same host. Right? Then a JSON could be the data.
Yeah.
But then if you would like to enrich the data of customer with some specific
So I think you would
something.
enrich it offline in another system, and then reload it back to jump. So for example, you're building an application, let's say a website, let's say a recommendation engine, right? So a recommendation engine for shopping. So you've got lots of data, complex data models. So you build that data model in another system, do analytics, and then get let's say every hour or every day, you would update the recommendation engine and put the final recommendations in memory on the online Gemfire. Then you could have millions of consumers hitting within 1 millisecond response to get the recommendation, but you don't do the recommendation there. You would pre-calculate the
That's what I understand, but for example, input stream may contain just user ID. It's not enough to do any scoring on user ID. You need to have some characteristics of the customer.
You do need some of the characteristics, absolutely. You do.
So
But you don't need the
how
whole thing.
the live stream of user IDs with these characteristics in Gemfire, is it possible or?
You take the parts of it that you need. So anyone who ever tries to take their dimensional schema and put it into Gemfire, I tell them, no, you don't want this product.
So it's totally no reference kind of thing, or is it partial references, or is it?
So we do have an object query language that is tailored to objects that can do simple joins, but at the expense of much, much slower than 1 millisecond. The fact is that as soon as you say the word join, you can't get 300 millisecond response. 300 microsecond response, rather.
Just on that, sir, just extending that question, so you have an order list, and so you have all the addresses are all denormalized kind of thing.
Orders,
So-
you're saying orders?
Orders.
Product orders.
Product orders,
Okay.
and somewhere you have some address, 1,000, you have 1 million record going to the same person, and suddenly the address changes, or something changes. What happens then, like in
So you'll still have the address in the customer record, but the customer record will contain a list of order keys rather than having to have a separate external index. You have a list of order keys inside of the customer record.
It all starts from what problem you're trying to solve, right? What is the system? And you gotta see the specific case then, right? But what the point is that you can get some really powerful feature from Gemfire, which is the low latency, millions of concurrency, and globally available across multiple places around the world. If you stick to within a box, right? If you stay within that box, you can get that benefit. And most systems can't do that. Can't give you microsecond response globally with HA, right?
Yeah. I mean, once you need to go to broader joins and things like that, we have another product for that. We have Greenplum.
But what about real-time stream that I need to enrich in real time? Yeah, how do I do this? Not in Gemfire then. What are the tools to do this?
Probably going to be Spring Cloud Data Flow is my guess.
Mike, in that implementation, just as a very broad brush example, is it of any use to say that Gemfire is kind of hyper-maintaining a super index on the fly that you can take a snapshot of and then go and join that to tables?
Well, what we do keep is an index of primary keys. Okay, it's a hash map, literally, of primary keys.
And that's being updated in real time from all different places.
Yeah.
So if you had some kind of query that had value from that, you could take it and go and do some stuff in a more traditional
Yeah.
environment.
Yep. It's a true key value store. So anytime you deviate from the key value way of operating, it deviates from the 300 microsecond access time. It doesn't mean you can't do it. It just means it deviates from the 300 microsecond access time. Okay? You're now going to get characteristics of a relational database, which is a much, much slower thing.
But still limited by your network, whether that's O2 or Orange.
Yeah.
So the only reason I say is you go 300 microseconds and I'm like, actually I'm not really sure what that is like as a user experience. So then there's other things that are going to slow this down. It might not be this architecture.
Well, so
Something else in the flow.
So
Well, yeah,
actually,
so if I'm Southwest Airlines, it's going to be, well, in my case, a Windows phone. So nobody will.
so inside of this one cluster here, you're going to get your 300 microseconds.
Yeah.
If you need to hop to another cluster, that's all bets are off on that.
Well, yes, that's what I'm thinking.
Okay. Okay, so now I'm going to get into those. Yes, I am. I'm going to get into those multi-site active design patterns. There are a few. There are about a half a dozen of them. The simplest one in the world, I skipped over it, actually. Simplest one in the world is plain old disaster recovery, unidirectional, just replicate. Okay, everybody knows how to do that one. We do something different on that one, and it's worth noting. We do bidirectional. And the reason we do bidirectional is anybody's database can fail over. Very few databases can fail back for you. We can fail back. Okay, so the multi-site stuff starts getting interesting when you start to apply design patterns to it. This is what I call the exchange pattern. You have the New York Stock Exchange, the London Stock Exchange, the Tokyo Stock Exchange. If you're going to trade IBM, there's only one place in the world you can trade IBM. That's where it lives. Okay? So what that means is that the transaction manager for an IBM trade is located here. Not there and not there.
It's non-overlapping keys.
So it's a completely separate access pattern for the different exchanges. Okay, and then we have a pattern that we call, or I call, the realm manager pattern. This uses a very special pattern, sub-pattern within Gemfire, which is we call the command pattern. Command pattern is basically I'm going to do a put into a region that is a command region with a request that says, do some operation for me. That will get replicated around the world, and whoever happens to have access for this particular customer, write permission for this particular customer that you're requesting this on behalf of, is going to execute it as fast as it can. So if it happens that this guy has permission and not the guy closest to you, it's going to run at wide area network speed. But that's a way of segmenting work so that you'll never have a collision. You can take that concept further and you can achieve what I call a global trading book. So when you're trading in the currency markets, you need to have at all times one trader in the world responsible for a particular currency pair. Okay? It's not a law, but it's definitely how you do it. Okay? That guy doesn't work 24 hours a day, so he has to pass the book to somebody. And then that somebody has to pass it again 8 hours later. Okay? And so using this scheme of having a token that says where the permission is to trade this thing right now, and using the pattern I just showed you that somebody has permission to do the right, I can now give you a global trading book. I can give you pass the book around the world.
Mike, does that help some of the jurisdictional requirements?
That in itself doesn't, but we do have some stuff that does. Okay, another thing that's very common, this is extremely common for trading municipal bonds in the United States. You're not allowed to sell short on municipal bonds. So and there are many, many venues for selling municipal bonds. And so the way we handle that is we put part of the inventory everywhere. Using a global map for municipal bonds doesn't make sense, but forgive me, okay? The idea is we're using that same pattern. We're asking someone to trade on our behalf, or we are segmenting the inventory in such a way that we can't collide. In this case, we're segmenting so we can't collide. My favorite pattern doesn't work in financial services, but it works pretty good for selling sneakers. Has a little story behind it. The story goes like this. I have a sneaker sales shop, and I have a promise that I make to my customers that I'm going to do same-day shipment every time. And one day, somebody buys the last pair of sneakers, and as I'm going to put it onto the truck, the forklift runs it over, and I'm not shipping the same day. Well, now I need a way to apologize. Well, just take that to extremes, and that's why sometimes your seat is oversold on your airplane. That's how they do it. Okay, so that's all the patterns. This is the implementation of one of those. I talked about the currency trading. So the first thing I did with Gemfire all those years ago in 2002 was I built a currency trading system at Merrill Lynch, and it was in fact New York, London, and Tokyo based. And I had traders in New York, London, and Tokyo, each managing some of the currency pairs. And they had the pass the book problem that I described. And you can't imagine how horrible it was the way we were doing that before on Sybase. It was minutes to pass the book on the phone, minutes on the phone, trying to get to the point where you could see the same thing. And see a snapshot of the same thing as of minutes ago. Once I got the WAN gateway in there and used Gemfire to do it, we got that problem down to seconds. And in the process, we replaced a whole bunch of kit and software. So we got rid of the Sybase database in every region. That paid for the Gemfire software by itself. We got rid of the TIBCO rendezvous for local area messaging because the eventing that's built into Gemfire is just as good, if not better. In some ways, it's better. We got rid of the MQ series to pass the stuff around the world. And we even got rid of the extra node in the clustering because we don't need an extra node in the clustering. So that's the Gemfire story. I'll take any more questions you've got. I've got 3 minutes.
Any questions for Mike?
Question.
Yeah.
You said about like in a distributed system when you've got like the remote WAN replication. You said the last byte wins for config resolution across two systems.
That's the default.
How is time defined? So, because in order to define what last is, there needs to be a definition of time. So there's some kind of a vector clock, or how is time defined between the two systems?
We keep a version vector on every single key in the system.
Okay.
And a timestamp. And there's
If
some,
it's split, how do they keep a consistent version?
and if it splits, our notion of last is cluster with the lowest number as its name. So we'll give you something consistent. It may not be correct, but it'll be consistent.
Okay.
You'll see the same thing everywhere. We also give you the ability in the WAN gateway filter to plug in your own consistency modifier, so that if you know how to rip apart the two transactions that you're seeing and re-glue them together so that you have the right answer, you're at liberty to do that. There is a plug point for putting that in.
What's big look like in terms of number of nodes? Because we hear scale a lot, and then up to 3.
So with when it was all heap-based, we kind of recommended don't go beyond a couple of terabytes. Now we're saying 10 terabytes will be easy.
How many servers?
And so years ago, that would have taken 100 servers. But servers are getting so big now, and with the off-heap, I can put a quarter terabyte on one server in memory. That's not actually true. Let me just step back on that for a second. We have a notion of redundancy, right? So we have some redundant copies of the data. And if you're going to do a big data set, you're probably going to do like Hadoop and have 2 redundant copies. So you're going to have 3 copies of the data. Okay. You also have to have, so right off the rip, you've only got half as much as what you have total memory in your box, right? And we've also taken away 30 gig for working storage. So you've only got, 3/4 divided by 2. So when you do the math, it comes out to you still need, more than 4 boxes to do a terabyte.
50 computers would not be unreasonable.
Not at all. Not at all.
But this is also regarding the concurrency and the number of sessions you will have to manage on the grid. No?
So one of the things that's nice about Gemfire being horizontally scalable is if memory isn't your constraint and processing power is, well, just go ahead and scale out. And that also begs the whole thing about scaling the app tier separate from the memory tier, right? You'd love to have your cloud-native applications be completely stateless, right? That's a wonderful thing in cloud. That way cloud can kill off anything, anytime, and nobody ever cares, okay? And so if you can put all your state inside something like Gemfire, which itself is cloud capable, then you can have your apps be completely stateless. All of their state is living in Gemfire. They're getting 300 microsecond access time, so they're very, very, very happy with that. And best of all worlds for cloud.